Okay, 5.1. 5.1. Let's talk about 5.1, shall we?
Yeah, that's exactly.
Isosceles equilateral triangles. We're just going to talk about lots of different kinds of triangles today. Okay. So, you have an acute triangle. Acute triangle is a triangle that has all angles that are less than 90 degrees. Yes? Okay. These are probably things that you know already. You know what I'm saying? We're just going to kind of review some stuff. Right triangle has one 90-degree angle. An obtuse triangle means that one of its angles is greater than 90. An equilateral triangle, okay, all sides are congruent and all three angles are congruent. That's important to remember, because if they tell you in the directions this triangle is an equilateral triangle, then that means I can figure out what the angles are, I can figure out what the sides are. It's not hard, okay? An isosceles triangle has at least two congruent sides and at least two congruent angles. And then a scalene triangle, okay, has no congruent sides, no congruent angles. So there are 6 types of triangles we need to be familiar with. Acute, once again, acute has 2 angles that are less than 90. A right triangle, it has 1 angle that's exactly 90. An obtuse triangle has 1 angle that is greater than 90. Then you have an equilateral triangle where all the sides are congruent and all 3 angles are congruent. And then you have an isosceles triangle where at least 2 sides are congruent and at least 2 angles are congruent. And then you have a scalene triangle where none of the sides are congruent and none of the angles are congruent. Okay, how do you feel about that? Okay, so triangles all add up to be how many degrees? 180. So if I know one of those angles, or if I know one thing, I can start to solve for stuff for triangles. Okay? I'll give you one more minute and then we'll move to the next page. Okay? So 6 classifications of triangles. We're going to get some rules for triangles today. We're going to solve some problems using triangles today. Fun stuff. Because all of my shapes can be broken into triangles. Except for circles. Well, circles we can do something to make them into triangles later on. We'll talk about that in chapter 11. Okay. So here it says, the measure of angle B is 4 times the measure of angle A. And the measure of angle A is 20 degrees. What type of triangle is triangle ABC? Sketch the triangle. Okay. So A is how many degrees? Okay. And B is what compared to that?
1 times 20.
So then the measure of angle B is 20 times 4, which would be what? 80 degrees. So then what would be, what would be the measure of angle C then? 80 degrees. So what type of triangle do I have? That's what the question's asking. If 2 angles are congruent, then it is isosceles. Okay? So you have an isosceles. I-S-C, right? Is that how it's spelled? Isosceles. And then it says sketch the triangle, so you can just pretty much sketch them however you want, as long as 2 of these sides are congruent, right? Because on isosceles, 2 of the sides are congruent, and then these angles would be the ones that are congruent. Okay? So you're going to have problems like that tonight on your homework. Can you handle that?
Yeah.
Mm-hmm. Yes. Okay? Not too bad, right? Okay. Then it says, let's move this up. Let's see. Okay, it says, based on its sides, what type of triangle is triangle ABC? Use the distance formula and the slope formula. Okay? So here we have a triangle that's on a grid. This point right here is clearly 0, 0. What is this point right here? 6, 4. Yes. No. Yes. 6, 4. Okay. And what is this point here? 2, 3. Okay. So it says, based on its sides, what type of triangle is triangle ABC? Use the distance formula and slope formula. Why do I have to use both? What do the slopes tell me? It would tell me if it's a right triangle, right? Okay. The distance formula is going to tell me the length of each side so that I can narrow it down to equilateral, isosceles, scalene, those type of things. Okay. So does this take a little time? Yes. Is it super hard? No. Okay. So let's find the distance of AC first. Okay. How do I find the distance of AC? Okay. So 4 minus 3 squared plus 6 minus negative 2 squared, yes? Okay, what's 4 minus 3? 1. 1 squared is 1. What's 6 plus 2? 8 squared is? So you get the square root of 65. Just leave it like that for now. Here's why I'm saying that. If it's not perfect square, leave it like that because all I'm doing is comparing the side lengths. So I don't need to know the decimal. If both come out to radical 65, they're the same thing. Okay? Don't do extra work. Let's find CB. Square root of 0 minus 4 squared plus 0 minus 6 squared. So what's 4 squared? 16. What's negative 6 squared? 36. What's 16 and 36 added together? 6 and 6 is 12, 34, 52.
Yeah.
Okay. Now we need to find the length of AB, right? Or the distance. AB, let's do 3 minus 0 squared. I did y first, didn't I? Oops, I did y first on that one. Okay, plus, it doesn't make a difference now. Negative 2 minus 0 squared. Okay, what is 3 squared? 9. What is negative 2 squared? 4. So what is 9 plus 4? So what type of triangle do I have?
You got what's the one on the far right? The bottom right?
The bottom right over here? You're correct. It was a scalene, right?
Oh, because none of them were the same.
None of the same length. So I have a scalene triangle, okay? I have a scalene triangle. And then it says, and the slope formula, I'm going to assume that the angles aren't the same, but we can see. They might, because if they're, they could be parallel or perpendicular. So the slopes for AC is changing y over changing x, right? 4 minus 3 over 6 minus negative 2. 4 minus 3 is 1 over 8, 1/8, okay? B, or CB is 4 minus 0 over 6 minus 0, which gives you 4/6, which reduces to 2/3, yes? And then the other one, oh, this is gonna be a good one, okay. BA, or, yeah, AB, whatever, however I wrote it, AB is going to be 3 minus 0 over negative 2 minus 0, so you get negative 3 seconds. What do you notice about 2/3 and negative 3 seconds? They're opposite reciprocals, so what type of triangle is that?
Right.
A right triangle, so it's a right scalene triangle. So in your answer, you would have to say a right scalene triangle. Okay? Does that make sense? Okay? Is that simple enough? Pretty easy, okay? So it's a right scalene triangle. That's why we gotta double check the slopes as well. Yeah, go for it. Okay, so if you know the distance formula, if you know the slope formula, you should be set to figure these things out with triangles right now. Go for it.
Can you just send it to you?
Send it to me.
So,
Bryson knows exactly where it was on the screen.
Yeah,
That was
you know, I
good.
don't need this.
Caleb.
Yeah. Okay.
He's gonna write on this.
So, so that is what that looks like. That is how we're going to start classifying triangles. So you're gonna have a classification from each section, the top and the bottom. It's either gonna be acute, obtuse, right, okay, one of those three from the top. And it's going to either be equilateral, isosceles, or scalene, okay? So it's gonna be like two of those things combined every time. That's why we've gotta check both the slopes and the, the slopes and the distances. Okay, there are theorems, lots of theorems today. I know. And I will bring the others back up. There are theorems. Isosceles triangle theorem, okay, isosceles triangles. Tell me, if two sides of a triangle are congruent, which is the definition of an isosceles triangle, then the angles opposite of them are congruent. So if I know that these sides are congruent, I know that those angles are congruent because of the isosceles theorem. Okay? So if two sides are congruent on a triangle, the two angles opposite those sides are congruent. So if AC and BC are congruent, I know that angle A and angle B are also congruent. If angle A is congruent to angle B, then side AC is congruent to side BC. So isosceles triangle theorem includes more than one thing. It doesn't have a converse because it's all written in one, so it covers both ways. Does that make it a little bit easier for you? Okay. So that's the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. If two angles of a triangle are congruent, then the sides opposite them are congruent. Pretty simple. Pretty much gives you the definition of an isosceles triangle right there. What, Faith? Okay. Isosceles bisector theorem. Here's the great thing about the bisector theorem. When you bisect something, what does it do to it? Yes, it divides it into two equal parts, okay? Two equal parts. So if I bisect an isosceles triangle, I create two right triangles, and I can start to solve for things. So the isosceles bisector theorem says, if a line bisects an isosceles triangle's vertex angle, okay, if it does it from the vertex, then it is perpendicular, it is a perpendicular bisector of the base. So that then means that if this line BD bisects angle B, okay, the vertex of that triangle, then BD is perpendicular bisector of AC, which makes AD and DC congruent. It gives me a 90-degree angle. I can start to solve for things. Okay? Because all triangles equal 180. And now I have three triangles in that one picture. Yet all of them are going to equal 180. Okay? So that's,
You say you have three oh, okay.
Yeah.
I got it.
you see what I'm saying?
Yeah.
I have
The big, the large one.
and then the two small ones. Okay, so that's the isosceles bisector theorem. There's a converse of the bisector theorem. So what do you think the converse is going to say? If the theorem says, if a line bisects an isosceles triangle's vertex angle, then it is perpendicular to the bisector of the base, what would the converse say?
If the line is perpendicular.
Yes. If a line is perpendicular to the base, basically, then it's going to bisect the vertex. Okay, so I can work it backwards. If I need to prove that the angles are congruent, I use the bisector theorem. If I need to prove that I have, if I need to prove the angles are congruent, I use the bisector converse theorem. If I need to prove that the side lengths are congruent or that it is perpendicular, I use the normal theorem. Okay, so isosceles bisector theorem converse. If a line is perpendicular, if a line is the perpendicular bisector of an isosceles triangle's base, then it is also the angle bisector of the vertex. So if line BD is the perpendicular bisector of AC, then segment BD bisects angle B. Okay? Those are three pretty simple rules, I think. Yes? Can you remember those We'll get them into our minds, and they're all to do with isosceles triangles, okay? So these only apply to isosceles triangles. You can't apply it to a right triangle, you can't apply it to a scalene triangle, just an isosceles triangle. Understood? Okay? Because isosceles have 2 equal parts, so it makes my life better. Makes your life better, you'll see. Okay. Give you a few more seconds to write, and then I'm switching screens. What?
I do.
Okay, let's look at this. Okay, so they wanna know what is the measure of angle A? Okay? How do you think we could figure out what the measure of angle A is? Okay, Kayla, what?
Split it, we do, you know, isosceles bisectors there, and then we measure, it. So we, like, so it equals one triangle, so we do 180,
Okay.
and then add 90, 32, and then 8 for X.
Okay, yeah, good. So, what we're gonna do is, we know that this is an isosceles triangle because this side and this side are congruent. We know that this is the bisector, okay? A perpendicular bisector of it, because it shows it to us. So since it doesn't say prove anything, all I have to do is set up an equation that says 90 plus 32 plus angle A equals 180, okay? So 90 plus 32 plus the measure of angle A equals 180 degrees. So 90 and 32 is 122, right? And then I subtract 122 from both sides. And the measure of angle A is going to equal what? What's 180 minus 122? 58 degrees. Yeah. So this is 58 degrees. Question for you here. If the measure of angle A is 58 degrees, what is the measure of angle C? What is it? 58. Why do you know that? Because it's isosceles. What is the measure of angle B? No. If I say angle B, that means I want the whole angle of angle B. 64. If they want to know what the smaller part is, they're going to name it either angle ABD, like they'll give you 3 letters with it. You can say DBA, or you can say CBD, okay? They're going to name it in a way so that you know it's the smaller one they're looking at. Does that make sense? If they say angle B, they want that whole angle, okay? Whoops, gonna die. Okay. Equilateral triangle theorems. Okay, now this is for an equilateral triangle. What does an equilateral triangle tell us? All the sides are equal, all the angles are equal, okay? If 3 sides of a triangle are congruent, then the angles opposite them are congruent, okay? So what it's saying is, if side AB is congruent to BC and congruent to AC, then that means angle A, angle B, and angle C are all congruent. Basically, once again, the definition of an equilateral triangle. If 3 angles of a triangle are congruent, then the sides opposite them are congruent. Okay. So below we have a rhombus, okay? And it says, what are the measures of angle A? What are the measures of angle ABC? Okay? We're going to talk about this a little bit. What do you know about a rhombus?
It can be broken
Looks
into
like that.
2 triangles.
It can be broken into 2 triangles. What about the sides? What do we know about the side lengths of a rhombus?
They're congruent.
They're equal, okay? So if I break this into 2 triangles by cutting a diagonal through it, pretend that's perfect, okay? What does that mean about those two triangles? They're equal, so it is a, what type of triangle?
Oh,
Equilateral, which means all of these sides, right, are equal, doesn't matter where I go. So what would be the measure of angle A?
60.
No,
Oh, wait, 120.
120, yes. What is the measure of angle ABC?
We were in, why is it?
Yeah. B is 60 and then C is 120 and then D is 60.
We're gonna talk, if it's 120 or if it's 60, okay? So here's the deal. I know that these two triangles each add up to be 180, correct?
Yes.
Okay, so if I have an equilateral triangle, what does that mean about each of these little angles then?
They're equal?
They're equal, yes, okay. Okay, so if I have, two triangles and the insides all equal 180, that means two triangles insides equal what total?
120?
Now, what's 180 plus 180?
Oh,
360. So inside of that rhombus, it all equals 360, correct? So how do I figure out what one angle equals then? Take 360 and do what to it? Divide by 4 is what we're saying. So what's 360 divided by 4?
90?
This is kind of a trick question.
90?
Okay, but is that a square? Do we know that that's a square, that it's 90-degree angles everywhere?
Yes.
Okay, so here's the deal. Okay, when you divide this, this doesn't become an equilateral triangle, even though you want to think that it does. When I divide this like this, you know that this is 90 degrees, right? So if that's 90, what does this part have to be right here?
45.
What?
45.
45. And then that means that this part is also, because this whole angle is 90. Okay? So it didn't make equilateral triangles when you cut the diagonal through there necessarily. You have to think it through. Does that make sense? How we work backwards from there? Okay? So you know that a rhombus has 90-degree angles, okay? And from there I can go. Unless they specify, because some rhombuses might not be exactly 90, because they might be like, more shaped like more shaped stretched out, like different side lines. And then we'll have to figure out from there, but they'll specify for you, okay? Oh, constructing an equilateral triangle. Okay, constructing an equilateral triangle. When you are constructing an equilateral triangle, you want all the sides to be equal and all the angles to be equal, okay? So once again, I'm not just getting out a ruler and constructing this, you're gonna use a compass. Okay, so you begin with a line segment. So they started with this one line, AB, okay? I have one line, I need to make an equilateral triangle out of that one line, okay? In order to do that, you have to make an arc from point A, okay? You're going to extend, well, maybe I would if somebody didn't steal my compass. I don't think I have a compass. Okay. So what you have to do is you have to extend your compass to the length of AB, okay? So I make it the length of AB. And then you place the compass point at A and you draw an arc. That's how they get this whole arc. You just draw an arc, okay? Then you place your compass at point B and draw an arc. Boom. And I make this massive arc, okay? When you do that, you get an overlap. That's where you put point C. Now you connect the lines with a ruler, a straight edge, and you get your equilateral triangle. It's pretty simple, okay? Can you handle doing that, do you think? It's not that hard. Okay, these are the steps broken down. Line, okay? And then they show you, after your line, you make your arc like this, okay, cause you extended the length of that. Then you come back up here and go to point B and make your arc. And then you connect your dots, okay? So that's what you're focusing on tonight, isosceles and equilateral triangles.